So we talked about how a function has to be one-to-one, and one of our favorite functions, the parabola. Say it looks, oh, I can't even draw a parabola today. Say it looks something like that. That's not one-to-one. Pretend like it's going through the origin. So what we do is we restrict it. We take off half the parabola. So we're just going to kind of get rid of half of the parabola like we did in the water trough problem. And we're only going to focus then on half of it. That then becomes a new function, and it's one-to-one. Because we restricted it with something like x is greater than or equal to 0. And then we only have that half of the parabola, and we're okay. We can find the inverse. Okay, so we have an example, and I want to show you what it looks like with a graph and everything. Let's see if I can make this just a little bit bigger. Okay. So it says find the inverse of the function. Okay, now let's think about this function that they give us here. Well, we know it's a quadratic function. We know it's shifted 4 units to the right. But they give us this restriction that x has to be greater than or equal to 4. So if I go 1, 2, 3, 4 to the right, if I were to draw my basic parabola like I'd been doing with transformations, 2, 3, 4, it would look like this. Okay, so we've done that before when we did transformations. But this part right here says, oh, by the way, x has to be greater than or equal to 4. And so what happens is we won't be, well, that took out all my parabola right there. I have to draw in just this half. Okay? So that's the only piece we have for the parabola, is just the one side of it, where x is greater than or equal to 4. Now, if you're saying, well, what if I wanted the other side, the left side of the parabola? You could do that. In fact, we're going to do that on part B. Okay, but that's not what this question asks. This question asks us to find the inverse. Okay, so we're going to use this restriction then, and now we're going to find the inverse. So we're going to say y equals x minus 4 squared, where x is greater than or equal to 4, and then we're going to switch x and y. Now, I like to do this. I like to write over to the side that y has to be greater than or equal to 4, because I switched the x and y. You don't always see it written that way, but I like to write it that way. Okay, now I have to solve for, and I'll tell you why at the end, I have to solve for y. So that's going to mean I need to take the square root of both sides. And when I do that, I always put a plus or minus in, right? Okay, so we'll get back to that. So plus or minus the square root of x equals y minus 4. And then I would add 4 to the other side. So I'd have plus or minus the square root of x minus 4, or plus 4, equals y. Now, here's where this part comes in. Because y is greater than or equal to 4, and I'm adding here, right? So I need this to be a positive number, because if it's negative, then it would be less than 4, and I know my y has to be greater than or equal to 4. So it's going to be the square root of x plus 4 equals y. And then I'm actually going to write that with the inverse notation. So f inverse of x is going to equal the square root of x plus 4. That's one of our toolkit functions, and so we actually know what this looks like. It looks like the square root function shifted up 4 units. So if I take my square root function, if I remember what that looks like, and I go up 1, 2, 3, 4. Let's see, 1, 2, 3, 4. And it's going to look like this. Okay? Now, if you remember back to when we did inverses before, we said a function and its inverse are symmetric about the y equals x line. And so if you were to fold on that diagonal, the orange part of the original function would line up with the black part of the inverse that we have drawn there. And that's what the function and its inverse would look like. We had to restrict it so that it would be a one-to-one function, but that's how it works. Okay, so now we're going to show you the other part. So now we're saying, oh, we're going to have the same function, except now the restriction is different. It's going to be less than or equal to 4. So if I were to graph it, 1, 2, 3, 4, we're talking this side of the parabola. Now you might be asking, well, how do you know which way to restrict it? It's really up to you and what you're using it for. I usually see them restrict it to the positive side or the right-hand side of the parabola, but there could be reasons why you would want to restrict it the other way. We're just showing you both ways in this case. But now it is 1-to-1, so we can look at it that way. Now we're going to go ahead and do the inverse, which I don't think there's going to be any surprises here, but let's just write it out. And we have x is less than or equal to 4. So when we switch the x and y, so take the square root. Like I said, I wasn't thinking there were too many surprises here because we already did this. But now here's where this comes in. The y is less than or equal to 4. If my total over here has to be less than 4, then I need this to be the negative case. So I need it to be negative square root x plus 4 equals y. And then I can write that with the inverse notation. Negative square root x plus 4. And we actually know what that looks like. That's a reflection and shifted up 4. So it's going to be a reflection about the y-axis and then, or the x-axis, and then the whole thing's going to be shifted up 4 units. Okay. By the way, x has to be greater than or equal to 0 here because it's a square root, and I should have written that on the previous one as well. Okay, so if I think about my square root function and reflecting it, so it would be like upside down, going like that, but I have to shift the whole thing up 4 units, so let me go 1, 2, 3, 4. 1, 2, 3, 4. And then it's going to have a point there. And then 1, 2, 3, 4, 2. So it's going to be going like this. Okay. So these little points here were just helping me get my reflection there. But that's what it would look like. And again, if we were to draw the diagonal, you can see that if you fold it, the orange graph will line up with the black graph, okay? And that has to be for inverses, and they were 1-to-1, so it all worked. Okay, so what I was saying, we know that x has to be greater than or equal to 0 because it's a square root function, and I should have written it here too. X is greater than or equal to 0. I don't think they asked for the domain and the range.